NASA burns $3 billion yearly keeping the ISS running. Private companies could cut that cost in half, operating stations for just $1 to $2 billion. But who's going to build them? Starship offers up to 3,000 cubic meters of space, dwarfing the ISS's 935. It's made of stainless steel instead of fragile aluminum, costs under $20 million per launch, and could go up fully assembled in one shot. What if SpaceX already has the perfect space station design, and nobody realized it yet? Let's dive right in. The space station market is about to explode. We're talking $1.8 trillion by 2035. Space tourism alone is growing 25% yearly and could hit $3 billion in revenue by the early 2030s. Companies see orbital research, biomanufacturing, even movie production in zero gravity as the next gold rush. So naturally, everyone wants a piece of it. But can they actually pull it off? Voyager Space is building Starlab. Axiom Space has ambitious plans. Blue Origin is in the game. Vast is pushing forward. They've got investors lined up, billions in funding from major players like Janus Henderson, and reusable rockets slashing launch costs. The momentum is real. Yet there's one massive problem nobody wants to talk about: the price tag. These stations cost between $1 and $4 billion each. Finding investors willing to bet that kind of money on an untested market? That's brutal, especially when one technical failure could destroy everything. And it's not just about money. Every system has to be perfect. Air recycling, water purification, radiation shielding. In space, almost safe means people die. We've seen rocket failures before. History proves that even the best engineers make mistakes. Then you've got regulatory headaches. NASA wants these stations operational by 2030, but new safety regulations take years to finalize. Add supply chain delays or rocket setbacks, and timelines slip fast. Meanwhile, China's Tiangong station is already up there, operating smoothly. The pressure is on. But here's the twist. The biggest threat to these companies isn't technical challenges or tight deadlines. It's SpaceX. How can anyone feel confident investing billions when their biggest competitor has a secret weapon that solves nearly every problem they're facing? Here's where Starship changes the entire game. SpaceX has been developing the core systems for a Starship base station since 2021, when NASA awarded them $2.9 billion for the HLS lunar lander variant. The basic design, already done. To convert that into a low Earth orbit station, they'd only need another $1 to $2 billion. Compare that to the ISS's $150 billion total cost. The math is staggering. Elon Musk estimates a single Starship launch could cost under $10 million. Even conservative estimates put it at $20 million max. What does that mean? SpaceX could theoretically launch 20 Starships, link them together in orbit, and create a giant rotating loop generating artificial gravity. 20 fully reusable spacecraft, each one capable of returning to Earth for repairs and upgrades. Can traditional space stations even compete with that? The reusability factor is a total game changer. If a component fails on the ISS, astronauts have to patch it up in space or wait months for a repair mission. With Starship, the entire module could detach, return to Earth, get fixed in a proper facility, and relaunch within weeks. It's like comparing a car you can never take to a mechanic versus one you can service anytime. Which would you trust for a decade-long mission? And then there's the material choice. The ISS uses aluminum alloys. Starship uses stainless steel. That might sound boring, but it's actually genius. Stainless steel is cheaper, stronger, more heat-resistant, and doesn't corrode like aluminum. It handles micrometeoroids better, withstands radiation more effectively, and survives extreme temperature swings without degrading. Long-term maintenance becomes dramatically simpler. Why would you choose the fragile option when the tougher one costs less? But size is where Starship truly dominates. The main living section in the upper payload bay is 18 meters tall and 9 meters wide, offering roughly 1,000 cubic meters of pressurized space. That's already bigger than the entire ISS at 935 cubic meters. One spacecraft, more volume than a station assembled from dozens of modules over 13 years. How is that even possible? It gets wilder. If SpaceX removes or repurposes the massive internal fuel tanks, a fully converted habitat could offer up to 3,000 cubic meters, 3 times the ISS, 3 times the room for labs, workshops, crew quarters, storage, greenhouses. Future Starship variants, like version 4, are expected to provide over 1,000 cubic meters right out of the gate, no modifications needed. What could humanity accomplish with that much space to work with? Starship wasn't even designed for low Earth orbit. It was built for deep space, Mars missions, lunar landings, months-long journeys through the void. If it can keep astronauts alive during an 8-month trip to Mars, maintaining life in low Earth orbit is almost trivial by comparison. The life support systems, radiation shielding, thermal management, all already engineered for far harsher conditions. Does that give SpaceX an unfair advantage, or is it just smart planning? Picture the interior layout. 6 full decks stacked vertically like a space apartment building. Storage areas, a gym, a greenhouse growing fresh food, communal spaces, private crew quarters. Or, if operating as a stationary station in microgravity, SpaceX could rearrange it horizontally like a submarine, stretching 3 long decks from nose to tail. That enormous volume opens possibilities competitors can't match. Full-scale laboratories, engineering workshops, a zero-gravity basketball court. Why not? But Starship isn't operating alone. It's part of an integrated ecosystem SpaceX already runs. The Super Heavy rocket serves as the reusable launch platform. Dragon capsules deliver supplies and rotate crew members. Starlink satellites ensure constant high-speed communication and data links. Everything works together under one company. No coordination headaches between multiple contractors. No competing schedules or incompatible systems. Doesn't that sound like a massive operational advantage? SpaceX is already testing Starship version 3. The plan? Launch to orbit in 2026 with a key mission demonstrating in-space propellant transfer. That's not some distant dream. It's next year. So it's not a question of if SpaceX can send a Starship-based station to low Earth orbit before 2030. It's when. Every other company is still assembling modules, testing connections, securing funding. SpaceX is already flight testing the actual hardware. Who's really ahead here? There's another fascinating angle. Starship offers a throwback to the Apollo era. Instead of launching multiple modules and assembling them in orbit like Axiom or VAST plan to do, SpaceX could launch a fully built station in one shot. NASA did exactly this with Skylab over 50 years ago. One launch, entire station operational. Modern technology makes it even easier now. Why hasn't anyone else tried this approach? Inside SpaceX, there's talk of a dedicated Starship Station variant, a purpose-built version designed specifically for orbital life from day one. Instead of modifying a deep space Starship after launch, this variant would be constructed on Earth with everything pre-installed. Life support systems, laboratories, crew quarters, radiation shielding, power systems. Ready to operate the moment it reaches orbit. It could even include Dragon-style thrusters for station keeping, maintaining altitude and orientation without external help. Would that be the ultimate space station design? No matter which route SpaceX chooses, converting an existing Starship or building a dedicated variant, the result is the same. A massive, durable, completely reusable structure that can be upgraded, repaired, or replaced as technology evolves. Traditional stations are stuck with 20-year-old technology until retirement. Starship stations could swap out entire modules whenever better systems become available. Which approach makes more sense for long-term space infrastructure? Now, SpaceX hasn't officially announced plans to build a giant Starship-based space station in low Earth orbit, but they're not sitting idle either. They've already entered the commercial space station race as the key enabler behind the scenes. Axiom Space relies heavily on SpaceX for launch services and crew capsules. They buy or lease Falcon 9 rockets and Dragon spacecraft, then package and resell those missions to paying customers worldwide. SpaceX provides the transportation infrastructure while Axiom handles the customer experience. It's a partnership that benefits both sides, but who really holds the power in that relationship? So here's what we know. NASA spends $3 billion yearly on the ISS. Private companies could cut that in half, But building new stations costs $1 to $4 billion each, with massive technical risks and tight deadlines. Meanwhile, SpaceX has already developed most of the core systems through their $2.9 billion NASA Lunar Lander contract. They'd only need another $1 to $2 billion to convert Starship into an orbital station. Their launch costs? Under $20 million versus traditional approaches costing hundreds of millions. The vehicle offers 3 times the ISS volume, uses tougher materials, and can return to Earth for repairs. It was designed for 8-month Mars missions, so low Earth orbit is actually easier. Whether SpaceX builds their own station or continues enabling companies like Axiom, one thing is clear. They're shaping the future of orbital infrastructure right now. The ISS retires in 2030. Someone has to replace it. Every competitor is still assembling modules and securing funding. SpaceX is already flight testing Starship version 3, with orbital demonstrations planned for 2026. They're not just in the race. They might have already won it before anyone realized the starting gun fired. The real question isn't if Starship becomes a space station. It's whether anyone can compete when it does. What do you think? Could SpaceX dominate the next era of space stations, or will traditional companies find a way to compete? Drop your thoughts in the comments below. If you found this analysis valuable, hit that like button and share it with anyone interested in the future of space exploration. And don't forget to subscribe to Space Update 24 Hours so you never miss our coverage of SpaceX's next moves. We'll see you in the next episode.